All right, here we are. We got our cups of coffee. We're
We're
talking
ready to
about
go.
AI in the morning. Super, super pumped. John, why don't you introduce yourself?
Sure. Yeah.
Yeah.
So my name's John Lawler. I'm an assistant professor of IT analytics and operations at Notre Dame's Mendoza College of Business. I do research on AI model development, specifically around making them more efficient, more interpretable, but then also looking at the kind of socio-technical impacts of AI in the workplace, in online communities, and other environments where you've got human AI interactions in new and unique ways.
Absolutely. I mean, huge, super hyper relevant topic today. It's just crazy how fast everything is moving. So, what is your bet that Skynet is going to take over in 10 years?
I start with the big one. Um,
We're just jumping in. We're just
Guess
going.
yeah, this might as well. The Skynet takeover, I would bet I'd have pretty low odds on that. Higher odds on human AI, uh, some combination of human AI making unintended effects and unintended outcomes based on over reliance on automated systems, things like that. But it wouldn't be
Hmm.
Skynet; it would be Skynet with a well-intentioned human or malintentioned human at the control board.
Yeah, that it's really interesting because you have good actors and bad actors, right? And then that kind of gets into this idea of should this super powerful technology that can learn on its own, that can do things in the hands of people who have no idea what they're doing, in it getting out. So this goes to like the open source, right, versus closed
Mhm.
source argument. Where do you kind of stand on that? What are your thoughts with it, whether it should be open source, closed source, a combination of the two?
Yeah, I mean that's a really good question. I'm generally in favor of the open source side of the argument. So, especially in my research, I try to open source as much code as I can in terms of like, here's how I designed my experiments, or here's the implementation of the algorithm I'm proposing. Where it gets tricky, especially with like large language models, um, just because something is open source doesn't necessarily mean that it's useful in the way that like an open source algorithm from a few years ago was useful, right? Because these large models, the kind of secret sauce is really the model weights, right? So you've got the difference between like a llama and a GPT, or pick your off the shelf LLM, is basically those raw values that are encoded under the hood as like the weights of the network that
Hmm.
do the transformations to make the predictions and make the generations. And they're all just numbers, right? So you could
Right.
open source these numbers and really not learn a whole lot. Um,
Hmm.
so it's a different paradigm than it was. Now that said, if they're open source, then like the research community can interrogate these models with like particular probing tasks where I want to know exactly what happens with this input prompt, like what's going to spit out.
Hmm.
So there certainly is a lot of value there. Um, but it's much different than before, where like you could just look at the code and know exactly what's going to happen every single time you run the algorithm. Now you've got these just huge matrices of numbers that you'll eventually learn what they do, but you have to run a lot of tests, a lot of probes to see, okay, what's going to happen in this scenario, what's going to happen in that scenario. So there's a lot of value on the open source side, but it takes a lot more work to get at this kind of notion of transparency, interpretability, understanding what's going to happen than even a couple of years ago.
Sure, sure, for sure. So you know, talking work. So from my standpoint, somewhat of a layperson, knowing some tech and things like that, we have these large language models that a lot of the new technologies are based off of. So you're thinking ChatGPT, even like Mid Journey using the image generation, and basically what they are, and correct me if I'm wrong, are these massive, massive data sets that then teach, if you will, the AI how to interpret certain questions and give a potential output. Is that kind of what the language models are, right?
Yeah, yeah, that's pretty good. The thing I would add is that um, give a potential output, right? You typically have some kind of signal, whether like when you're training these models based on that data set you mentioned, whether it's a good output or a bad output, right? So you
Mm-hmm.
can
So you say
see,
yes,
okay,
no, that's
right,
right, or that's not
exactly. I
right.
like this one. I don't like that one. And then those weights I mentioned, those values, those are adjusted so that the next time around, the output, whether it's an image or a text, whatever, is a little bit better. And then better can be defined in certain ways to decide how you're going to make those updates.
Absolutely. So this is kind of a very nerdy tidbit that I think is true. So is it true that CAPTCHA, when you're kind of going into a website and you had to prove that you were human, and then you chose the images that had the the stop signs and the images that have the buses, wasn't that developed by a professor, I think, at Carnegie Mellon, who said, we're actually going to train models as you're doing that? Like, it's a good security test, but we're also going to train. Is that true?
Yeah, yeah. And if I recall correctly, it's the Duolingo guy whose name I can never remember.
Yes.
But yes, yeah, he invented capture with the intention of data collection. Yeah, yeah.
Yes. So that was kind of that was like the baby steps for all the social media
Yeah,
companies to just gather loads of data on all of us when we don't really know what we're doing. It
right.
was sign that privacy policy, check that box,
Yep, yep,
and
yep. And then from there, it's scaled to just anything you put on the web that a crawler can access is just going to get sucked in. Yeah.
absolutely. So what's the difference then between something that can just have loads of data, right? And like an image selection software or something where you say this is what I want, and then it gives the output, to something like ChatGPT, where it is just this, seems like this behemoth of knowledge and understanding. Is it just a collection of all of this data in one thing, and then it provides an output, and it's just woven together almost like a quilt? Or how does that work exactly?
So at a relatively high level, the earlier systems were very targeted, right? So thinking about capture, like, is this a cat? Yes or no, is like a very specific question, right? Either it's a cat or it isn't. So you've got a clear prediction, yes cat, no cat. You've got a clear reward or output. You were
Mm-hmm.
right, you were wrong, and like that's a very kind of closed system that can be trained to do better on that particular task. So a couple of years ago, people realized that a lot of tasks could be framed as well. Originally, it was framed as question answer, but you could turn like sentiment analysis, where like, is this movie review positive or negative? Everything could be framed as a question, and then all of your supervised learning, your classification tasks, became questions. So then it kind of lumped tasks together. With LLMs and their predecessors, um, it turned out that a lot of tasks could be turned into fill in the blank tasks. So now you have like sentence completion tasks, or like tasks where certain words are missing from inputs. Now all these models, instead of predicting like, is this a cat, yes or no, or is this a positive review, yes or no, they're just predicting the next words and sequences of words. And then you set it up where, okay, I want my sequence of words to start to set up a sentiment analysis task, or I want to start to set up a paragraph generation task. So then these models got really good at predicting, what's the probability
Mm.
the next word is this? And then given what I've already said, what's the probability that the next word is that? Um,
Got
and
it. So
that,
it was a layer. It was like a new
yeah,
layer, a
exactly.
cake that was put on that allowed it to, quote, think, if you will, based on probability and statistics.
Right. And
Given
then that,
all of the inputs, what do they think it would be with all the knowledge that they have? And
exactly.
then the kind of the nuts and bolt, like the actual physical architecture of the hardware running this has gotten that much faster to allow it to crunch all this data.
Right. Right. So the two kind of key things, one on the data side, like any text on the internet now is viable input because it's all sequences of text. So you don't need something like a captcha or like a very specific, human labeling task where you're going to say, this is this type of thing, that is that type of thing. It's all just predict the next token so you can get it from anywhere. And then, yeah, on the compute side, on the hardware side, like especially as GPUs, like graphical processing units, get bigger and bigger and bigger, those are like very well designed to handle exactly what these models need under the hood in terms of like a lot of parallel computations, all things happening at the same time, updating weights in parallel. So you've got this kind of like adding more data, bigger hardware, more data, bigger hardware, and that's been the trend we're on right now. Is just like things are getting bigger and bigger on both sides.
I'm smiling because this conversation, I'm so pumped. I mean, there's like this convergence of technologies, right?
Yeah.
And there are so many different avenues that we can go to discuss. One of the things that you mentioned to me, this when you said risk reward, which I know you weren't actually meaning risk reward for the thing, but saying it that as a metaphor. But the what it kind of freaks me out, because what if you can train the computer to actually feel, quote unquote, feels like a conditional, positive or negative conditional, what do you call it, psychology, right?
Mhm.
That would be, and in a way you probably that is kind of what you do, right? But it's a ones and zeros way of doing it, and not an actual, there's no, hormone difference, right, between a positive outcome and a negative outcome. It's more of an error code, right, that comes up.
Hmm.
But when there's like this anthropomorphization of technology, right, and the more humanoid robots we have, right, and the more feel or emotion that these language models have, from a user standpoint, it's you start to develop this connection, this relationship with a program, right? So it's interesting thinking about what is happening under the hood of these programs from a we try to humanize it, right? Um, so interesting. So
Yeah, yeah, for sure.
one of the interesting things I've always thought about. Did you ever watch the AlphaGo documentary?
No, I haven't.
Are you familiar with it?
Probably should
Highly,
have by now, but yeah,
highly recommend it. It
yeah,
is
yeah,
so for those who don't know, basically this ancient Chinese game called Go has a exponential more amount of moves. And I think it's something to the tune of like the amount of atoms in the universe, something it's
crazy high.
absolutely
Yeah,
insane, the amount of moves that can be done. When the first computer beat the world's best chess player, that was a huge deal in technology and evolution of technology. But people said it would never happen with Go. There's just way too many moves for the computer to do. Well, I think it was back in when was it 2015? Back
yeah.
maybe 10 years ago.
2016, 2017. Yeah, yeah. Because I was
Yeah,
definitely in my PhD when it happened.
yeah. The computer AlphaGo beat Lee Sedol, the world's best um, Go player, which was absolutely shocking. And for those, I highly recommend this documentary. It's on YouTube. It's free, and there's this moment where the computer makes this move and the player has this shock. They're like what move? That doesn't make sense. No human person would ever make that move. But it was the move that precipitated his loss, and he ended up winning, right? And what I read recently was that I think it took them several years to build this computer, but then they used a different way of training the next computer. And within 2 weeks, they built one that beat that computer, and then that one beat the top 40 Go players, no problem. Which so that kind of shows this idea of just like compounding, right? So one of the things I wanted to bring up, why I brought this up, was this idea of the black box, where there are outputs coming from these models that researchers, so they say, is this true or is this hyperbole? They don't know how it's coming up with that answer. Is that a real thing?
Um, yes and no. So to link it back to the AlphaGo thing, like the technique they use is something called reinforcement learning, which is kind of
Mm-hmm.
related to this whole how you get your data question. Um, and the idea there is like you set up your signal, right? Like this is a good move, this is a bad move, but it doesn't have to be good move, bad move based on some human's understanding of the game of Go, right? It's good move, bad move based on the specific kind of function we've defined to give me a +1 if I do this and a -1 if I do that. That makes things interesting because when you get these really complex models with basically lots of parameters, lots of things happening under the hood, and then a reward, an output that says, if you do this, good. If you do that, bad. Then the inner workings of the model are going to change to satisfy that reward function, and not
Mm-hmm.
necessarily satisfy the intention of the person who, built the game, understands the game of Go, things like that. So there, it's a black box in the sense that like once you kind of tell this thing to go run a reinforcement learning loop where it's going to typically in something like Go to play against itself or another version of itself, and then the reward function will dictate like how the models learn, et cetera, et cetera. But once that process kicks off, you move away from here's the way a human would play Go, and then you move into here are these models that are designed to satisfy this function that is based on doing well at Go. So you've got this like level of abstraction away from
Mm-hmm.
like playing the
Mm-hmm.
game versus satisfying the constraints of the reward function. And then it gets into this kind of black boxy scenario because the model is doing stuff that like when you observe it's like, okay, this is doing better at Go, but what it's really doing is just spitting things out because this function told it was a good thing to spit out,
Mm-hmm. Mm-hmm.
Um,
So there's almost like a malleability or a flexibility written within the code to say, these are the rules of the game. These are things that you can do, and then kind of go with it as you will.
yeah,
Right?
exactly. Yeah. And another
And
good
it's
example
going
was
to
like,
think
yeah,
about it in potentially different way because humans might think about it in only a few different routes, whereas it's almost like a gosh, you can almost think about it like a 3D sphere of thinking, right? But there's almost an infinite amount of routes that it can think about, so long as you have different data within that sphere, right?
Yeah, exactly. Yeah, and one of the other games that played originally with that paradigm was Breakout, I think. And there's a
Mm-hmm.
funny video. Um, it figured out that for Breakout, as long as the it moved the main bar to a corner, like it could hack the system and just bounce it back and forth,
Oh, I
basically to
saw
just keep
that.
breaking. Yeah, right, exactly. So that gets it the most points. But like, is it playing Breakout, or is it just like pulling those points in? So yeah, things like that. Like it's this kind of step away from the game versus the reward function, I guess,
It's
or the
like
feedback.
it's it's like that annoying savant that enters a tournament that basically picks out, the one thing that no one has ever seen,
Yeah, just
and then
exploit it.
breaks the game in half because they're like, wow, this was something no one ever predicted.
Right, right, exactly. Yeah, yeah. So we're
Wow,
seeing
that's
that loop, going from chess to Go to some of these other games to whatever the next thing is. It's like, we think we have these well understood ideas of, how the game was designed or how it works, but then you get these like edge cases that get exploited or like these unique patterns. And,
mm-hmm.
with Go and with some of these other games, like you see, um, people are now learning from like what AlphaGo did, or like in chess, you've got these like hybrid systems where humans and an AI will play together, and you get these novel moves or like these unique tournaments where I think they call it like centaur chess, which is just this crazy thing to observe. It's like human plus AI are just coming up with these wild moves against another human plus AI. Um, so it's
That's
yeah, there's
what it's
people
called.
still playing chess. Yeah,
Centaur chess.
Centaur, I believe. Yeah,
That is wild.
um, I think Gary Kasparov was like a proponent of it. He's like, look, if you just play against an AI, like it knows the move space, so it will beat you. But if you have one on your team, you've got the kind of human creativity plus the AI knowledge of all of the move spaces, and then you pit that against another creative human and a different AI, or even the same AI, and you get these very interesting back and forths.
Wow, I love that. That's super, super interesting. I mean, because Kasparov, right, one of the world's greatest chess players of all time, absolute legend, but basically saying, hey, I mean, might as well if I try something new.
Right, right, exactly. Yeah, yeah.
Wow, that's really wild. Now, one of the things, so I try to balance between being really excited about AI and then also terrified at the same time, right? So every time I think of something that could be really good with AI, then I think of something that could be really bad with AI, right? This kind of going to this idea of allowing AI to quote think in ways that we wouldn't. I think it was the CAD software company partnered with Airbus. I'm pretty sure Airbus, the Boeing competitor,
Hmm, hmm.
and they were developing different pieces for an airline, and they said, okay, we want to make this type of I don't know structure, right? What do you think it should be? And then it popped out with an idea that was 30% lighter, saved X amount percent of materials, and human engineer said we would never think of that particular thing. This is amazing. How do you see AI being used in this area of just trying to? I know we've heard a lot of different use cases, but what are the most exciting ones that you've heard of? And where are you? What are you looking forward to the future?
Yeah, I mean, so it's obviously a big question, right? Because you've got things as different as like AI for writing documents to AI for design and then like manufacturing and physical space and things like that. Um, the biggest thing, especially in like the short term, to me, is opening up, taking like specific pieces of pipelines and improving them, right? So if you think about that Airbus example, like you've got a new design, that piece, like the design piece, fits in a bigger production pipeline, right? So it's not like the AI is designing the ship, building the ship, flying the ship, and then it's going to take off and plane tuning that ship. But you've got a design that can now go to, um, you know, the test team, like the team that then validates it, and if it works, great, you've built a better plane, which is fantastic. So those kind of things where it's still very well defined tasks that you may not know if this thing that the AI spits out is like better or worse, but you can test it, you can validate it, you can see that there are these kind of specific gains. That to me is where I think there's a ton of low hanging fruit, and especially because like you get people, or you hear sometimes it's like, okay, it's going to take over everything, or it's going to displace all these different things. I'm actually more interested and excited about like the very specific things it's going to take over. Like, what's that one task that it can do better, or it can do in conjunction with somebody to get those like quantifiable efficiency improvements, as opposed to just like doing it, which is harder to measure, harder to quantify. So um, things like that kind of design, there are certain automatable tasks that, just like there's always in the workforce, like before AI, it was, you'd have like, what do you call them now? But like you had the robotic task automation, like RPA, I believe, robotic process automation, where you could just automate these very specific sequences of, lead generation or whatever it might be. Now you're just doing that in a different type of way with different types of tasks. So anything that's
Absolutely.
kind of like, quantifiable, very measurable, those are the ones I think there's a lot of room for improvement.
So there's a newsletter I subscribe to, and I've it's called the Rundown. I don't know if you've heard of it. Super high end, very high quality. It was kind of the inspiration for me starting the Gen Creative, um, because every time I get in my inbox, I want to look at it. It's just very high yield. What's happening in AI and tech community right now? It's almost every time I open it up, there's another aha moment. Oh my gosh, I can't believe it's doing X. Right. For you, what was the can you remember a time where AI wowed you? Like, what was the first time it really blew your mind? You're like, holy cow, I can't believe this came out. And are you still having those experiences even though you are knees deep in this?
Yeah, I mean, that's a good question. So like during my PhD, I was working on um, recurrent neural networks, which were, a step below like transformer architectures, which are underneath all of the LLMs at the moment. And, we're working on very specific tasks, but I would play around with like trying to do sequence generation. Like, can I build sequence, to just write a certain type of output? And it was bad to say the least. Like, you'd get very noisy text, text that didn't make any sense, a whole lot of gibberish, things like that. So as that continued to progress, just the quality of text that got spit out of these models um, has been my kind of just like tracker to just see how those are doing. So when it moved from like, okay, it's pure nonsense to, okay, it's nonsense, but like it's identifying certain keywords that seem to be appropriate to, okay, this is a sentence that if you squint makes sense, to the very clean prose that comes out now. Like that progression has been really cool to see. Um, and then couple that with, okay, it's text that makes sense, but is actually doing something useful, or like, answering a question, things like that. Because that was a big shift when it went from, all right, these models are doing like very specific classification for like a very well-defined task, like we're talking about with the image captioning, to you can give this model any kind of task as long as it's well-defined, and then get the output.
Totally. So for
You're
you, it
breaking up
was
there a
kind
little
of
bit. I
this.
can't hear you.
Yeah, you broke up a little bit too. You good now?
Okay,
Can you hear
sorry.
me now?
Yeah.
No, it's okay. Good.
Yep.
So for you, it was kind of like a slow progression of what aha moments, right? Little by little, it was kind of starting it in your program, and then it was just like, wow, this is really going somewhere, right?
Yeah. Yeah. So the slope was definitely, um, I guess, a little more gradual, right? Because you're kind of seeing the progression along the way. And it's interesting because like we have these research conferences. So every year you go and, hear the latest research, and every year you kind of see things are moving forward more and more. And now there were definitely jumps. Like there was one year where the transformer like was proposed, and that was a huge deal because you're tracking all these performance benchmarks, and these models are doing pretty well and they're getting a little bit better. And then you see one new paper that just kind of blows all the benchmarks out of the water. So that was eye opening.
Mm-hmm.
So you have these jumps for sure, and then along the way you've got inclines. It's not like a pure step function. It's basically you got to jump up and then a little bit of a progression, and then another jump and a little bit of a progression.
Absolutely. Yeah. I kind of felt that progression with image generation, like the AI image generation software. So one of my silly things, prompts that I use for all these image generations is a panda dressed as an explorer, trekking through an otherworldly jungle.
Okay.
Right. It's just like a fun, kid thing. Right. And
Yep.
it was the first time I did that. It just looked this jumbled mess. and then I put motion to it, and it looked like this panda having a seizure with a backpack, like falling over trees, basically. To now, it is like an actual animation out of Pixar, right? And the total, it's just hockey stick. Every 3 months, it seems like it's a hockey stick. And one of the softwares I saw recently that just kind of got released within this past week was a Chinese company that you can play a video, and as you're trying to see which camera angle you want, you can actually go within the 3D space. So it's playing, and the subject is in the center of the room, and you're able to move the camera around in an entirely 3D space. So this idea that creativity is liquid now, and you can see this with vibe coding. Okay, what is your? Can you explain to folks what vibe coding is? And I'd love to hear. Like, I can make an app. I'd love to hear what you think or about vibe coding in general. How useful do you think it is? Can you actually deploy things quickly? But can you explain that for folks who don't know what we're talking about?
Sure. And on your Panda point, are you familiar with Ethan Malik, the professor from Penn who does a lot of like Gen AI work?
No, but I should.
So
I
he
should
has another
reach out
great
to him.
newsletter that I'm feeling you would enjoy. But his
Yes,
is I think it's an otter on a plane trying to connect to the Wi-Fi, very similar to what your prompt was. And he did a great blog post recently that just tracked the evolution of what comes out when he gives that prompt. And it's the
love
same thing,
that.
it's a mess
Awesome,
at
awesome,
first,
awesome.
yeah, all the way through to vision or to video. Yeah, the vibe coding thing is very interesting. So at a very high level, some of these large language models, they predict sequences of text to write documents or prose, but a lot of them have also been trained on code bases that are available online. So things like GitHub or other software repositories. So they can now predict sequences of Python code, C++ code, whatever it might be. So now with a free text prompt or like, prose prompt, hey, can you build me XYZ? One of the outputs can be a sequence of code. So that in a nutshell is vibe coding. You can interact with the model using natural language to output structured code that you hope can do something. I don't do much vibe coding. Played around with it a little bit, uh, but the impression I get from looking at some of the outputs and also just reading into it a bit more is similar to with the airplane example. The more structure you can put around the vibe coding, the better, right? If you need a very specific algorithm for a very specific task, the model can do that great because more likely than not, there's something like that online on GitHub or another software repository or something close enough where the model can use that as part of its generation to fill in the blanks. Uh, and that's super interesting for me, especially on the teaching side, right? Because a lot of my homework assignments are going to be exactly that, right? A very well structured task that you have to define and you want a very clear output that you can grade and be part of an assessment. So that has been a journey in terms of how we do assignments and assessments for coding classes, trying to figure out a way to assess the material, in a way that the students are generating the code or generating the responses. Um, but as you zoom out, as you try and get like a larger, more um, unstructured task done, like build me an app. Well, what kind of app? Oh, I think it wants to be like a to-do list or something like that. That's one that you see a lot of because it's
Mm-hmm,
fairly
mm-hmm,
straightforward. Um, there are a lot of to-do app code bases online that the model can pull from, build things like
mm-hmm,
that. But then you get into this idea of like, what is the goal, right? Like if you're getting something that like
mm-hmm,
looks like a nice UI mockup, can do it pretty well. If you have to integrate it with a larger code base, then it gets a little bit dicey. If you have to deploy it, well, that's a whole different process, right? Because you're not dealing with the server, you're dealing with access, you're dealing with web requests, all those kinds of things.
mm-hmm,
So
mm-hmm,
as the level of complexity increases, the chances of the vibe coding session becoming um, more unwieldy
mm-hmm,
increase as well.
mm-hmm.
So yeah, so it's a matter of kind of scope and scale, how it's going to actually help. I think it's awesome that people are able to like say what they want and then get some notion of a kind of structured code base out of it. Um, but you run into potential disconnect between like, okay, I think this is going to work, but like I've now said this and I don't really know what the code means. So if I run it, it works, but then it doesn't work down the line in a certain edge case. What am I going to do to debug that? Then you need that programming or that kind of software engineering mindset to say, okay, what are my edge cases? What are the test cases? More
Hmm.
very structured pieces to kind of flesh it out, I guess.
For sure, for sure. Yeah, I definitely went down an app rabbit hole. What can I build? How can I do it? You know what I mean? And with the very, very basic understanding of all of that. I know one of the things that these models have gotten better at is asking questions back to the user, right? So you saw at one point, maybe it was 6 months ago or 8 months ago, where all of a sudden GPT and Claude and Gemini and all these were like, gave X amount of questions of how do you want to proceed. And from what I've seen with the vibe coding apps, that's the similar thing. Do you want to add a database? Do you want to add a login? Do you want to add a credit card processing? Do you want to add a whatever? You know, but they're definitely not perfect. And you run into an error, and then you say, hey, I have this error. You can just copy and paste the error into it. And says, oh, let me just QA that. You know what I mean? But then it never really gets it right. It's
Uh-huh.
just like the 85th percent or the 90th percent of what you're trying to create. But I have the sense that it's going to be the point where you say, build me X app, and it's going to just build it. And then it's going to be very little than just, putting in the plugs of the third party, plugins like a payment processor or whatever. It's probably going to come extremely soon. So I want to, and I know I talked with Steven on the last podcast about this because he's also a professor, is how is education must be so different now with your assignments that you have to give and testing the students on their knowledge, making sure they're really learning and they're not just throwing it into the GPT to get the answer for their assignments. How's the department? Like, how are you guys all thinking about how to effectively evaluate students and make sure they're learning what they need to learn?
It's a huge question, and we're thinking a lot about it and thinking constantly about it, like both in the department, the college, the university. Everybody's kind of trying to figure it out at the same time. And of course, course by course and like discipline by discipline, it's going to be very different. For me in particular, I teach like some coding courses in terms of like intro to coding courses. But then I also teach our like PhD level machine learning course to our business analytics PhD students. So for them, I kind of have an expectation of like, look, you guys have to learn this stuff because you're going to be researching it, building it, things like that. So we're nitty gritty, like in the weeds with all the algorithmic formulations that underlie these technologies. And then, they need to understand that level to then do their research. And in between, if they are coding something, I expect them to write the code themselves or rely on, the tools, but they are responsible for what they're building and how they're using it. With the undergrads, it's interesting because these are business analytics majors, so the expectation is they're kind of in both worlds where you're on the kind of product design, system design, the kind of business side, but then also more on the technical side in terms of like building maybe a data analysis pipeline that you'll work with someone with more of a pure computer science background to implement or to improve, enhance things like that. So there, I'm much more interested in them understanding conceptually what's going on with certain like unstructured analytics um, So, before you even get to something like an LLM, there are things that you can do around like understanding a corpus of text in terms of like how many tokens are showing up, how frequent are certain phrases, topics, things like that, that rely on relatively straightforward algorithms, and you can still get a nice kind of structured output from them before you even go to an LLM. Um, so in the class, like I kind of tell them, like if you're going to use an LLM to help you with the code, you're still responsible for what you send in to me. So like,
Mm-hmm. Mm-hmm.
if there's code that helps you solve this problem, you can use it. You can kind of cite it, full transparency. But what comes to my desk is your output, right?
Yeah,
Um,
totally.
so
Well, I
that
mean that because you have to. I mean, there's this. I know with coding, there's like efficiency, right? So you can do things. You can say a lot to get from A to B. You can do that in a lot of different ways, but it can be one page long or it can be 1,000 pages long to get to the exact same output. So I'd imagine that they still have to be able to evaluate that code, make sure it's just like it's the exact same thing as saying, "Hey, help me write a script or help me write a paper." It's going to make a little bit of mistakes here or there, or they're going to say it weird, and then you got to make you have to have the knowledge of how
Right.
to say it in order to
Yeah.
say it well.
Exactly. Yeah. And with a lot of their assignments, there's typically like, um, another step to whatever the code was spitting out. So like you've done the piece that requires some coding. Now take what it gave you and then draw some insights or make some recommendations, right? Because you're kind of setting up an environment where you think you're working for a company or it's like a case study kind of a thing. So it's not enough to just get the code to spit something out, whether you wrote the code or the AI wrote the code. You take that and then do the next step. So if you're getting poor outputs from your code, whether you wrote it or whether the model wrote it, it's going to affect that next step in the pipeline. So
Absolutely.
kind of breaking it down into these tasks that build on each other help. I think, you apply the concepts, you write the code, whether you do it or you get some help with the AI, you get your output, and then what, right? You take that, go to the next thing. So,
Absolutely.
and that kind of, I think, mimics what they'll see, right? Like they're going to be put
Mm-hmm.
in situations where like their job is to generate some insights or make some recommendations or, understand some process. And, if they just do it blindly and have no understanding, they can't describe it to their manager, they can't describe it to the stakeholder, things like that. But if they use an AI, understand it, and then are still able to make sense of it and then do that next step, they didn't necessarily have to write the code. They just had to make sure it was right and the outputs reflect reality, those kinds of things. So zooming out a little bit there, I think helps, me when it comes to designing the assignments, like what pieces require what linking to the course material. And it'll help them in terms of like, if we just ignore it, then they're not getting prepared for when they enter the workforce. And if we're, relying on it completely, then they're not learning the concepts that underlie the whole process.
Absolutely. Absolutely. Now, I just want to say, when do you have to jump off before?
7. So I got like
7.
15
Okay,
minutes.
so
Yeah.
we
Yeah.
have a little bit more time.
Yep.
Okay, awesome. So one of the things, because I think this kind of goes along with this, is I don't know if you saw it. There was this memo from the CEO of Shopify.
I heard about it. Yeah.
Did you hear about this?
Yes. Yeah.
Yeah. Did you get a chance to read it?
I didn't read the memo. No, I just
Okay.
saw it floating around. Yeah.
Yeah. So basically, for those I recommend everybody listening or reading it. I have all these recommendations. No, but the reason why I recommend it is because in this memo, he outlines how he wants his company to shift towards AI in every single role and capacity. And he straight up says, we're going to change our hiring and we're going to emphasize people who have AI understanding and prompt, skills. We're going to promote people who know these better than those who don't. And we are going to put AI agents in our organizational structure, like in the actual, what's the word for it? You know what I mean? Basically, the map of the employees, right?
Yeah.
We're
Like
going to
the
have
org
AI
chart.
agents. What's that? The org
The
chart.
org chart.
Yes,
Yeah.
thank
Yeah.
you. The org chart. So this changed it to me when I read that memo. And basically, when it first came out, everybody on X was like, oh my gosh, like this isn't crazy, like what they're doing. And then the CEO is like, okay, I know this is out already. I'm just going to put it on myself because I'm not going to be secret about it. And when I read that, I kind of go, holy smokes, every single company is going to adopt this if they haven't already. And he's just being straight up about it. And to me, we're still, and this is what gets me excited and also scared about AI and where we are right now, is because I feel like on average, nobody knows what's happening, right? Nobody knows. They might see that Siri has new AI capabilities and they can make a fun cat video from a picture, but they don't really understand the true implications of it. And it's to me that it shows how some people, there are going to be a percentage of people, like if you think of things on the bell curve, right? The third who get it are going to be safe. The other third who have no idea are not going to be safe, and they're going to get blindsided. What do you think about this idea of how the workforce is going to change, labor is going to change, organizations are moving faster than people realize? Do you think that's true, or what are your thoughts with all of this?
So right now, I think we're in a very interesting point, like you said, because it's just so pervasive, right? Like everybody now is at least has heard the phrase that like they should be thinking about AI in their employment or their organization, or they're trying things and learning and making adjustments as needed. But everybody seems to know that they should be thinking about it in some sense, right? And organizations, broadly speaking, are going to try and do what they can as efficiently as possible, right? They're going to try and maximize revenue maximize some kind of financial metric or shareholder returns, whatever that might be. And if AI is one of the knobs that they can turn to increase their revenue, to maximize their stock price, or to hit whatever financial metric they need to hit, then they'll turn that lever, like they'll turn that knob. But what's really interesting to me is like AI is a huge umbrella, right? Like, it all kind of fits now under this LLM idea, or like everybody has a picture of like, okay, some kind of like ChatGPT-esque solution is what we need. But, AI has been around since the 50s, the 60s. People have been working on some kind of like automated thing to do something that humans can do for a very long time. So it's good in the sense that like people are trying to find the efficiencies in their firms and trying to do things in a way that will lead to these benefits that hopefully will be measurable in terms of revenue, productivity, whatever that might be. But we're in a weird spot where like people are just painting with a very broad brush what could potentially be a lot of unique solutions to different contexts. So I'm hopeful that as people think at this very broad level, in firms and organizations, I need AI to fix this thing or do this thing for me. They take the next step to say, well, what is the thing specifically that I can do first to get some measurable benefit? Because, I'm actually now going to have to go read that Shopify thing. But like, to me, I'm going to throw AI at everything. It's just going to lead to a lot of trial and error, a lot of maybe short-term heartache and headache before you find the 3 or 4 things that it actually did work. And then you've got that benefit there. So couple that with, some hype. People think maybe like, okay, it's going to replace all entry-level employees, or it's going to do this or do that. I think there's a lot more room for kind of augmentation than pure replacement. Now that will lead to efficiencies that are found in the firm where you've got 5 people plus an AI that can maybe do what a 10-person team did before. But that is a more predictable and like manageable process because people have been implementing IT systems to increase productivity for a while now, right?
Yeah.
So I don't think it needs to be this like giant paradigm shift because there is a lot of history that can be built on. But it's very exciting, right? And everybody's like, okay, we got to do the AI thing. And I think you'll see a bit more nuance before any giant change.
Yeah. There are several points, in my exploration of AI the past couple of years where I was just like, holy cow, I cannot believe this just did this in this amount of time, right? So before I was in, dentistry, I was in business for a bit, and I was messing around with ChatGPT and marketing research. I go, holy cow, what I just did in 5 minutes took me dozens of hours when I was working at these marketing agencies. And that's when I'm kind of like, oh no, for the people who are coming right out of school. The thing that I think so as you were talking, right? So I'm concerned about that because are people going to lose jobs? But then on the flip side, you think of vibe coding, you think of all these other opportunities that are available where people can make their own businesses, they can make their own products, they can make their own whatever, right? Because of the abilities of AI, right? So maybe there is going to be a shift from labor force where there aren't going to be as many people working in these big corporations. Maybe they're going to be way more small businesses because there's availability of technology and products and et cetera. But then I think human nature is lazy. So if you think of everything on the average, most people, we tend towards laziness, right? Or, for jobs that a robot or an AI can do easily, how many people are actually going to want to really think critically about, all right, what do I do now that is productive to society without just wanting to chill and be on TikTok and play video games and whatever, right? Because all of those entertainment technologies like social media and video games and TV, movies are going to become even more engaging, right? They're going to try to make it and even if they say they don't, it's the truth. They're going to try to make it as addictive as possible because that's how they make money, right? That's where the scary part of AI comes in.
Yeah. So I think you need an ethicist on next to figure out the answer to that one. But it's true. It's like, you've got, I think, like I was saying a minute ago, like you've got efficiencies in the workforce that lead to pretty big changes in terms of who's doing what, how many people are doing what, certain fields shift or go away as technology makes changes. And I think what's going to happen is, once you get through the bumps of like, how's AI going to fix this? I wouldn't be surprised if, something akin to like, cars replacing horses on on roads and things like that happens in a much shorter span of time, right? You've got this like, no shift in technology, and like the effects of it can be super condensed into a much shorter time period. So the disruption might be more of a shock than like a kind of disruption that can be managed or dealt with
Exactly.
and things like that. So
Exactly.
that's tricky. And then you've got a bunch of people who, do they reskill? How are they, reintroduced to the workforce? How do they shift into a new position? And what their like motivation to do that is, or things like that. Because once, you could imagine a scenario where you have a shock like that, and then you have the next shock like that, like 2 or 3 years later, right? Because if you get to a point where, okay, we figured out that AI can do A, can it do B? All right, well, we're going to have it do B as well. And then somebody who is just retooled and reskilled to get to position B is displaced again, right? So there's a chance that you've got these knock-on effects that get messy. There's also a chance that like you've got, like you were just saying, like these smaller, leaner, large corporations, more entrepreneurial activity where people are able to do, what a 10 person team could do with just themselves and a, AI. So I think, I mean, it's very uncertain, right? And there's a kind of wide range. And I think what's most important, what is important at that point is like recalling and remembering, like you've got human dignity, you've got like people in this
Absolutely.
equation, right? That's the big thing to me that I always come back to. It's just like, we're talking about people, like it's the labor force, but there's also, these human beings, right? So we could replace everybody, but if we're going to do that, we sure should make sure that we're at least planning for these contingencies of like, okay, if we're displacing those people and we know it's coming, where, some shocks you don't know are coming, but we've got this sense that like something big is going to change soon.
Mm-hmm.
We should think about it maybe a little more carefully.
100%. The human dignity piece is huge, huge, huge.
Yeah.
I mean, it's like the unfortunate savage reality, right? Is that these
Right.
like big corporations, they just see, I mean, they just see numbers. I mean, and it's kind of, it's probably because as humans, it's basically impossible to think of the amount of influence that an organization or a person has. It's like Zuckerberg can't just think about the billions of users that he has. I mean, he thinks about them in theory, but he can't put a face to every single number. And it kind of gives me shout out to Pope Leo, right? But the reason why he chose Leo was because the Pope that has Leo the last time was during the Industrial Revolution, and he said, right, there's this idea of human dignity. We're not just a factory, et cetera, et cetera. But I think you're right. This idea of thinking about not just how can we be more productive, but how can people be, how can we give them dignity? One of the things I've been thinking about, because a huge motivation for me to kind of just start talking publicly about AI is I really fear for people's jobs. I really fear for it because I don't think that they realize, right? I have a lot of family who are in the creative sphere industry, and they would say, oh, and friends, AI is never going to replace us. People want the human touch, and I was like, I don't think you understand how much this is changing. So when I think about labor, we it seems like those entry level, like the data entry jobs, the administrative jobs, AI is going to take those over, right? But jobs that are going to be more challenging are, say, the trades, right? Because the amount of variables there are in, say, laying a pipe, doing electrical, doing plumbing, are infinite, and there's so much flexibility that comes into figuring out something and if you think about the real world, right? If you try to apply all of the thinking and physical actions that a human is doing in those scenarios, makes it very challenging for a computer because you have to be able to code all of those things, right?
Exactly right. Yep. Yeah.
Now, but a couple weeks ago, I saw Google came out with a new program that basically allowed its robotic systems to learn off of watching humans, right? So it's bringing in the visual data, putting it into the ones and zeros, training the model to be able to do that. And then I see, have you heard of Figure?
No, I don't know that one.
Figure is one of the big humanoid robot companies,
Okay.
a competitor of Tesla and Optimus. The founder had another tech company. I forget which, but recently there's like leaps and bounds of innovation, and you see they came out with a video recently of it sorting, basically sorting materials with its hands,
Yeah, yeah.
on a line, and then it was able to, a human went up to it and like put its hand out, and then it was able to like take it and pick it up and like give it to the human. That's a massively complex task, right? So yeah, really, really interesting with the labor thing. Okay, so I know we only have a couple minutes left. So one of the things kind of the last thing I want to hear from you is for those who are out there who are young, in the workforce, either just starting out or a few years in, for parents who are listening and their kids going to college soon or they're in high school, what is your advice on how people should prepare for this AI wave in terms of job prospects, being prepared for it, gaining the tools and the skill set? What's the advice that you give to parents, students, young professionals?
Yeah, that's a real good question. So on your last point, was interesting. My dad's a carpenter and my brother's a carpenter as well. So the trades thing is funny to me because like they're the ones like that I keep an eye on. It's like, okay, they still have a job. The AI's not coming from yet, but now I got to check out this new firm. Um, yeah. So for students, I'm big on like conceptual understanding and like the application of conceptual understanding to specific problems, right? So like generally speaking, an AI can do a lot, but when push comes to shove, like can it do the thing that I need it to do, right? Like there's a zooming in kind of like I mentioned earlier that I think is still really important, and it's hard to know if it can do it and if it can do it correctly unless you have some understanding of the goals of your task, the specific requirements, like that kind of nuance um, is really important because the kind of big point with a lot of these LLMs is like as you give it more data, as the models we get bigger, they're good at more things, they're like pretty good at more things, but when you zoom in, circumstances being unique enough, that's where the things will fall apart, but like that's where you need to be super careful. So I wouldn't say people need like a deep understanding, and not everybody has to go study AI or machine learning or whatever, but um, understanding at some level, like these are basically still prediction machines and they're working off probabilities. So some notion of statistics and things like that is super useful. But whatever field you're in, whatever you're interested in, I still do think that like there's a lot of good and necessary pieces of like knowing your field well and being able to translate that to, even if you're working on like a prompt design or, you're dealing with somebody who's coming to you with some AI generated output, contextualizing that, putting into a bigger pipeline, understanding, okay, AI does this well. Can I turn this into something that generates revenue, or can I turn this into something I can send, incorporate into my nonprofit to make sure that we can, raise awareness, right? There's always going to be more broad considerations than like, all right, question AI, answer, everybody's happy, right? So, um, whatever it is that you're going to do, I think you still need to understand your domain well, do it carefully, and allow this great tool, which does certain things well, to do what it does well, as part of your broader goals, broader considerations, and broader objectives.
Awesome. Thank you so much for taking the time to chat
Yeah,
today.
absolutely. It was a pleasure. Yeah, it was a lot of fun.
This was this was awesome. Where can people find you if they want to check out what you're doing, your research, and things like that?
So my website is johnlalor.net, Lalor, and that's where I post updated research. You've got links to different research publications and things like that. Uh, so that would be a good starting point for sure.
Perfect. Awesome. Well, thanks again for your time. Super, super appreciate it. Hope to have you on again soon. We can chat more.
Awesome, sounds good. Thanks,
All right.
Eric.
Yeah. Cheers.
That's it.